Welcome
Special
back
thanks
on
for
Shoaib
Mr. Haris
channel.
Ansari, who
In
gave me
this
the
channel, you
material
can
to make
watch
this
technical
video.
education videos, automobile, Islamic and other topic videos. Today I discuss on boiler air and gas path system. Kindly watch this video till end. Combustion air system. Combustion air system. Main components. 1 forced draft fan air inlet silencer. 2 FD fan inlet pneumatic guide vane. 3 forced draft fan, 4 steam coil air heater. 5 regenerative air preheater. 0.6 wind box. Combustion air flow diagram. FD fan air inlet silencer. FD fan inlet pneumatic guide vane. Forced draft fan impeller. Importance of regenerative gas air preheater in plant cycle efficiency. About 50% to 60% of the total heat content of the exit gases is captured and recycled, resulting in about a 10% improvement in boiler efficiency when compared to an identical unit without an APH. Explanation of seal leakages and RPH. The left blue line represents the bypass seal leakage around the air preheater into the warm airflow. The bottom blue line represents the bypass seal leakage, also called peripheral seals, passing the axial seals into the gas path. The red line on the right represents the bypass seal leakage passing around the air preheater aft into the cold gas flow. The top yellow arrows represent the hot radial seal leakage, while the bottom yellow arrows represent the cold radial seal leakage. Explanation of seal leakages and RPH. Combustion air system important parameters. Ambient conditions, temperature and humidity. FD fan outlet pressure, FD fan motor current. FD fan inlet vane position, SCAH inlet air temperature. Regenerative APH inlet air temperature. Regenerative APH outlet air temperature. Regenerative APH inlet air pressure. Regenerative APH outlet air pressure. Combustion air flow. Differential pressure across regenerative APH. Differential temperature across regenerative APH, excess O2. Why to check important parameters? The operator should have these important parameter values in mind while operating the unit at minimum load and rated load to assess whether the unit is operating efficiently or otherwise. Just as an example, if the unit is being operated with too much excess air, boiler efficiency will reduce as the extra air will carry away more heat to the stack. Similarly, if the combustion air is lower than required quantity, fuel combustion will be affected. Some fuel will go unburned and again boiler efficiency will reduce. Therefore, for optimum efficiency of the boiler, combustion air need to be fine-tuned through to trim controller at present manually by the operator. Another example is differential pressure of air path across the regenerative F. Normal value is around 55 to 60 mm H2O. Increasing trend of the differential pressure of air path above this value is a clear indication of APH basket choking by unburnt carbon and other flue gas solid particles. An early observation of this change in parameter by the operator can provide a good opportunity to resolve this problem at the best time without going into forced shutdown. All the above mentioned parameters must be observed carefully and any abnormality must be reported as soon as observed so that remedial actions can be taken at the earliest. As the combustion air is once through system, change in one parameter will affect other parameters taken from different points in the airflow path. The operator must be able to correlate this change by understanding the process. For example, if air differential pressure across RAF increases due to partial choking of baskets, FD fan air discharge pressure will also increase due to higher resistance at discharge. As a result, FD fan inlet vane will open further to cope up the air requirement and more opening of the vane can easily be observed by the operator. Effect of ambient conditions on combustion air flow requirement. In winter, less combustion air flow required due to higher cycle efficiency. Less fuel, less combustion air requirement, lower O2 trim. In summer, more combustion air flow required due to poor cycle efficiency. More fuel, more combustion air requirement, higher O2 trim. Importance of O2 trim control. For B&W boiler, air-fuel ratio is 16:1. The control system is designed to provide combustion air 16 times that of fuel for efficient combustion. O2 trim control is provided to maneuver quantity of air required for efficient fuel combustion. O2 trim control can be selected on auto or manual as per the requirement of the combustion process. When selected auto, Auto trim control sends O2 in the exhaust flue gas and maintain it at the selected set point automatically. In manual mode, excess air can be maneuvered by the operator as per his requirement. For effective auto trim control on auto mode, auto analyzer reading must be accurate and stable, otherwise auto trim control may not be as effective as it should be. Historically at S-Power, auto trim control kept usually in manual mode due to inaccurate, unstable readings from auto analyzers. Presently no auto analyzer is operative and auto trim control must have to be kept on manual. While operating at rated unit load, auto trim control value is kept between 55% to 60% in winter and 85% to 90% in summer season. Effective FD fan inlet air silencer damage. When FD fan inlet air silencer got damaged, the load become decreased due to inlet air blockage. After renewal of the silencer, remarkable improvement observed in combustion air system. FD fan inlet vane position noticeably decreased and FD fan motor current also decreased. Air inlet silencer damaged. Air inlet silencer reconstructed. Effects of damaged basket of RPH. When regenerative air preheater RAF basket got damaged, unit load become decreased due to blockage in path as well as heat not transfer properly and exhaust gas temperature goes high. Improvement in our APH performance after basket replacement. Our APH average air outlet temperature improved from 268 degrees Celsius to 300 degrees Celsius. Combustion air increased from 430 Th to 460 Th. Boiler furnace pressure decreased from 440 mm H2O to 360 H2O. Our APH combustion air diff press decreased from 120 mm H2O to 55 mm H2O. Our APH flue gas diff press decreased from 180 mm H2O to 110 mm H2O. Our APH outlet gas temperature decreased from 158 degrees Celsius to 148 degrees Celsius. SCAPH could be taken in service to preheat combustion air that was previously completely cut off due to high or APH outlet temperature 158 degrees Celsius, cold and hot end basket sheet patterns. Our APH damaged baskets hot end. Our APH fabricated baskets cold end. Our APH damaged baskets hot end. Our APH fabricated baskets hot end. Our APH fabricated baskets hot end. It was the first episode of Boiler Air and Gas Path System in which I described the air system, and next episode will be flue gas system. Please keep watch Show Views channel for more informative videos. Thank you to watching my channel. If you like my videos, please subscribe my channel and like, share and follow it. Special thanks for Mr. Haris Ansari who gave me the material to make this video.